All right, here we're looking at section 9.1. So our learning targets for this section are to use the Pythagorean theorem, then we're going to be using the converse of the Pythagorean theorem, and then we're going to be classifying triangles. So here's the Pythagorean theorem, and hopefully you've seen this before. So in a right triangle, and we're always talking right triangles when we're going to be using the Pythagorean theorem, right? I know that the square of the lengths of the hypotenuse is equal to the squares of the lengths of the sides. So I know that a squared plus b squared equals c squared. And c is always going to be the hypotenuse, which is across from my right angle. That's the biggest thing to keep in mind there. So now a Pythagorean triple is a set of positive integers, right? And integers means counting numbers, whole numbers, a, b, and c that satisfy the Pythagorean theorem. So here are some of the common ones that we use often. So some of these will be helpful to note, that if you see a triangle with side lengths 3, 4, and 5, it's going to be a right triangle. 5, 12, and 13, 8, 15, 17, and 7, 24, 25. Those are our most common Pythagorean triples. Some of these would be good for you to just start recognizing, so make sure that you can kind of see this and think about them. So now let's look at our first example. So find the value of x, and then tell whether the side lengths form a Pythagorean triple. So first I see I have a right triangle, so I know that I can use the Pythagorean theorem. So I take one of my side lengths, 5 squared, my legs, plus the other leg squared equals the hypotenuse squared. So now from here I can go ahead and do the math. Let me just click through some of this. Right? So I go ahead and write my Pythagorean theorem, I substitute what I know, and the order of these two doesn't actually matter. I can pick whichever one as long as both the legs go on one side and the hypotenuse goes on the other side. Then I go ahead and I do my 5 squared and 12 squared, multiply. I add, so I simplify. Then I take the square root of both sides, and here I want to always find the positive square root. So remember mathematically when I take the square root of a number I have both the positive and the negative, but here since I'm looking at lengths and distances, I want to be looking at the positive square root. So I know that this hypotenuse length is 13. So since the side lengths 5, 12, and 13 are all integers, and they work, they work in this Pythagorean theorem, then I know that those integers do form a Pythagorean triple. So here's example number 2. So find the value of x, and then tell whether the side lengths form a Pythagorean triple. So again, I see I have a right triangle, so I can use the Pythagorean theorem. But here's a little different. Here I'm given the hypotenuse and I'm asked for one of the legs. So again, I just write my Pythagorean theorem, I substitute what I know, and you'll see here that my hypotenuse is over on this side by itself now, and I have one of the legs here and the x squared. So now I multiply, then I'm going to subtract 49 from both sides, then I take the square root. And again, I'm looking for the positive square root because we're looking for distances. So the positive square root of 147, which I'm going to use the product property of radicals. Okay, so I'm simplifying my radical. And I use this 49 here because I know what the square root of 49 is. So if I was looking at this 147, I would say, is this divisible by 4? Because I know what the square root of 4 is. Or is this divisible by 9? Because I know what the square root of 9 is. So I look at all of those things, and I use that property. So now I know the square root of 49 times the square root of 3. So I end up with 7 times the square root of 3. And this is as simplified as I can get because 3 cannot be broken down any further. Okay? So my value of x is 7 square root of 3. And because that is not an integer, these side lengths don't form a Pythagorean triple. They still work and they form a right triangle, but it's not one of our special Pythagorean triples. So now here's kind of a real world problem. So the skyscrapers shown are connected by a skywalk with support beams. Use the Pythagorean theorem to approximate the length of each support beam. So the first thing I see is that the support beams are the same length, right, because this length and this length on both are the same, and they're right triangles, so I can go from there. So now I go ahead and write my Pythagorean theorem. My x squared equals 23.26 squared plus 47.57 squared. Then I go ahead and just find the positive square root, and I use a calculator to approximate, because I don't know what these mathematically are. So the length of my each support beam is about 52.95 meters. So I can use this whenever I have a right triangle. So now here's your first monitoring progress. See what you can do. So now here's our second learning target, using the converse of the Pythagorean theorem. So the Pythagorean theorem told me that I know it's a right triangle, so then I can find my a, b, and c. So now here that if my c squared equals a squared plus b squared, then I know it's a right triangle. So here I'm going to be given some side lengths and said, is this a right triangle? That's using the converse of the Pythagorean theorem. So here we go. Here's our first example. Tell whether each triangle is a right triangle. So let's look at part A. So C is going to be the longest side. That's just kind of where we're going to start, is C being the longest side. So now I'm going to plug these in and see if it works. So my C, which was the square root of 113 squared, we don't know, does it equal 7 squared plus 8 squared? So now I just go ahead and I do the math and I simplify. And I see that yes, 113 does equal 113, so I know that yes, this is a right triangle. So now let's look at part B. Again, I'm going to have my C be the longest side. So then I plug in the values and I kind of simplify. And I just do the math and I see that these are not the same, so it is not a right triangle. It's really close, but in geometry we don't want really close, we want exact. So again, I'm just using my Pythagorean theorem. Now this is the converse, remember, of my Pythagorean theorem, because I'm checking to see if I have a right triangle or not. So now here are your monitoring progress. Now you're going to be using the converse of the Pythagorean theorem to check if they're right triangles or not. So now we're going to be classifying. This is our third learning target. So here's our Pythagorean inequalities theorem. So where C is the longest side, that's what we're going to be looking at. The following statements are true. So if C squared is less than a squared plus b squared, then it's an acute triangle, right? We've been looking at right triangles, so now we're going to be looking at acute and obtuse. So if C squared is less than those, it's an acute triangle. And if C squared is greater than the squares of my other sides, then it's an obtuse triangle. So let's look at this in action. So the first thing we want to do is verify that the segments with these lengths are a triangle. And that's often what we have to do first, is do we even have a triangle, or will my sides not make a triangle? Then I have to figure out, is it acute, right, or obtuse? So I want to use my triangle inequality theorem to verify that they form a triangle. So I take two of the sides and I add them to see if it's greater than the third side, which it is. So then I pick two other sides and I add them to see if it's greater than the third, which that one is. And then I take the final sides and I add them to see if it's greater than the third. So these three all have to be true in order for this to be a triangle. Okay? So since for this example they are, I know that we're dealing with a triangle. So now I can answer the second part, is it right, obtuse, or acute? So that's what this is, just saying that this is a triangle because all three of these check out. So now I have to classify. So I take the longest side, so I'm comparing my c squared with my a squared and b squared. So I don't want to put a sign in here yet because I don't know what sign we're going to be looking at. So I substitute what I have, and remember that c is always going to be my longest side. So I substitute, and then I simplify, I do the math, and then I add, and then I see that c squared is less than my a squared plus b squared. So that tells me that I have an acute triangle. So the first thing I did was I made sure that I had a triangle, and then I could compare and see what kind of a triangle it is. So here's your last monitoring progress. See what you can do with these. So now let's look back at our learning targets. Our first learning target was to use the Pythagorean theorem. So when we use the Pythagorean theorem, we're given the information that we have a right triangle and we have two of the sides. It doesn't matter if it's one of the legs and the hypotenuse or both legs. We can use the Pythagorean theorem to find the other side length. Then we were looking at the converse of the Pythagorean theorem, and that's where we were given all three sides and asked to determine, is it a right triangle? And then we were classifying triangles, determining whether it was an acute triangle, a right triangle, or an obtuse triangle. So now that we've done all of this using the Pythagorean theorem, go ahead and work on the homework for 9.1.